Welcome to ClickMyProject.com. Let me discuss about the process SWICOM, an SDR-based wireless communication gateway for vehicles. Let me discuss about the abstract of the project. Performing wireless communication into vehicles which are equipped with hardware devices. Here proposed the software-defined ratio-based wireless communication gateway, that is SWICOM, which are used for vehicular wireless communication. The SDR technology uses software to perform signal processing instead of hardware devices. This approach allows the integration of multiple wireless devices into a single generic wireless gateway device, analyze the runtime performance, and estimate the worst case execution times analysis. It is the radio communication systems where components that have been typically implemented in hardware are instead implemented by means of software on a personal computer or embedded system. A basic SDR system may consist of a personal computer equipped with a sound card or other analogous to digital converter, preceded by some form of RF front end. Significant amounts of signal processing are handed over to the general purpose processor rather than being done in special purpose hardware. Such a design produces a radio which can receive and transmit widely different radio protocols based solely on the software used. Software radios have significant utility for the military and cell phone services, both of which must serve a wide variety of changing radio protocols in real time. In the long term, software defined ratios are expected by proponents like the SDRF Forum, now the Wireless Innovation Forum, to become the dominant technology in radio communication. SDRs along the software defined antennas are the enablers of the cognitive radio. Let me discuss about the flow diagram for our process. Initially, the RF antenna has received the RF signal. In the RF receiver, an RF module is a small electronic device used to transmit or receive radio signals between two devices. In an embedded system, it is often desirable to communicate with another device wirelessly. This wireless communication may be accomplished through optical communication or through radio frequency communication. For many applications, the medium of choice is RF, since it does not require line of sight. RF communications incorporate a transmitter or receiver. This stability comes from a fixed crystal design, which in turn leads to a comparatively more expensive product. Next, in the ADC, that is analog to digital converter, and discrete digital conversion are performed. After that, USRP interface based on the SDR technology. A basic SDR system may consist of a personal computer equipped with a sound card or other analog to digital converter preceded by some form of RF front end. Significant amounts of signal processing are handed over to the general purpose processor rather than being done in special purpose hardware. Such a design produces a radio which can receive and transmit widely different radio protocols, as referred to as based solely on the software used. In the OFDM receiver, initially input signal is generated randomly by using the conventional encoder can convert the input signal into binary stream. Adaptive modulation scheme used for modulating the input signal. All the subcarrier in OFDM blocks in COM-type pilot models. Some predefined subcarrier in each block serve as pilot. Fourier transform breaks the signal into different frequency bins by multiplying the signal with the series of sinusoids. Finally, the data has been retrieved from the DQPSK demodulator. After DQPSK modulator implementation, we have to perform the demodulator. Finally, the performance analysis has been performed as transfer rate and packet delay based on packet size which was transmitted through system. Also, they analyze the runtime performance of signal processing based on worst case execution time performance analysis. Let me discuss about the running procedure for our process. Initially, there are three signals are given into input, and one is sine wave, another one is square wave, third one is shortwave wave. We have to combine these three signals and convert into a single signal and pass that signal into RF signal generator. From that signal generator block, we can get the signal as a single signal. That signals are given to the ADC blocks, where analog to digital conversion has been performed. After converting the analog signal to digital format, we have to given pass into the DDC converter. In the DDC converter, digital down conversion process will be performed. In this block, we convert the digital signal into performing down sampling of the digital signal. After that, the resultant of the DDC signal is input to the USRP device. In the USRP device, user have to enter the acquisition of the received signal. Based on the user received input, we filter the particular signal, that is resultant signal, from the overall grouped signal, and that resultant signal is passed into the OFDM receiver block. In the OFDM receiver block, there are three blocks constructed. One is DQPSK modulator. The resultant signals are modulated using DQPSK, that is quadrature phase shift keying block. After that, the resultant modulated signals are passed into the FFT block, where the fast Fourier transforms are performed. In that block, the compressed signals are decompressed. After the decompressed signal are passed to the DQPSK demodulator block. In that, demodulation of quadrature phase shift keying are performed. Finally, we received the resultant signal and compare the resultant signal with the input signal. If user has been entered the input as 2, means we will receive the resultant signal is a square wave, because we are given the second input signal is square wave. So finally we got the output. After executing the process of the blocks, we obtain the input signal is this scope is combined signal of three signals, and this one is sine wave, this one is square wave, and this one is shortwave wave. Here I use the scale of one scale, so in the step size of 0.1. So after performing entire process, we obtain the resultant signal, and finally we obtain the square waveform that will be getting in this scope, that is data session output. We obtain the final output scope. In the input signal, we obtain the input waveform. Thank you.